It's sun time.
Yes, and it's sun time again 2018 because today marks the 1-year anniversary of one of the most celebrated events in humankind, the 2017 total solar eclipse across America. And for the next hour, you are in for a treat. We're going to talk science. We're going to look at the back in time. We're going to look forward. Basically, we're going to have fun with the sun. My name is Dwayne Brown.
I'm Dr. Yari Collado Vega, and thank you for joining us. This is the first total solar eclipse that actually went coast to coast in the United States for nearly 100 years. The path over the populated areas actually enable science and observations that most eclipses don't let you do, because it was actually over those populated areas. It was a historic event
That a lot of people witnessed, it impacted, and I gotta say this, you and I were on stage.
We were.
In the wonderful city of Charleston. Shout out to the folks, College of Charleston and the city, magnificent. We had myself, you, Alex, who's gonna join us.
Yes.
John Yembrick, Karen Fox,
Sean
Potter. If you guys don't recognize those names, go to the NASA YouTube channel. 4-hour show, 600 million. 600 million.
That's a lot of views.
That's a lot of people.
That's a lot of people.
So if you're one of those 600 million watching this show, and we understand you're watching this worldwide because it brings back memories, I know I'm excited. We're going to learn more about, again, the solar eclipse from last year and looking forward. But send in your questions. Join the conversation. We're going to have fun with the sun. Hashtag Ask NASA. And let's go down memory lane. We know where we were. You know where you were. Send in your pictures at hashtag Eclipse 2017. We'll post them up. The conversation on social media is exciting and you know, they remember that day.
Yeah.
And I want to give a shout out to the meteorologists. You guys were just amazing, telling the public about the eclipse, covering it, and we brought it to you through the eyes of NASA. And we're going to talk more about that and much, much more, Johnny.
Yeah. Can you remind them about the glasses?
You're right. So you guys remember, I think you have some too. You remember these guys, right? They were like gold. So if you still have them, and I hope you do, get them out. You're going to be able to use them again and again. And stay tuned here. Don't change that dial. We're going to tell you how you can use these, and we're going to have fun with the sun. So let's have fun with the sun. Let's bring on one of our favorite scientists who's here now.
So first of all, we're going to talk about what is a total solar eclipse, and to tell us more about that is Dr. Jim Green. Thank you for being here with us.
Oh, my pleasure. What a spectacular event it was. Just thinking back at what happened, you know, where I was at Idaho Falls brings back wonderful memories. But let's talk about what a solar eclipse is. You know, anything in the sun has a shadow, and the moon is no different. And so as the moon moves in front of the Earth and carries its shadow with it, that shadow then cuts across our planet. And every time it's at a different location, it takes a long time for things to set up such that it's a perfect alignment that allows people in the United States to see it. And as you can see, that shadow moves across the continent. This is the great total solar eclipse. And if you were in the eclipse area, you had a magnificent view because the size of the moon, as you see it from Earth, completely covers the disk of the sun, and the atmosphere of the sun pops out, something we rarely see. Now, what's really great is that NASA set up 120 sites, official sites, across the United States, with 14 of them in the eclipse path. And this was really a wonderful opportunity for us to share not only the science from 11 spacecraft, but all the other kinds of things that we were making measurements of. It was just a beautiful time for everyone.
Wow. So, Jim, as the agency chief scientist, that's a pretty big deal. You can talk all of science, right?
Yes, and of course there's some science I'm not as familiar with as others, but the agency chief scientist should have a good overview of everything that's going on in the agency. And that includes not only our major astrophysics, planetary science, heliophysics, and earth science, but also the science that we do on space stations. So that's life science and microgravity activities. It's truly mind-boggling to try to get your mind around it and then yet be able to communicate that. It's exciting to do, and I'm just delighted to have the opportunity to do that.
You know, there were some interesting things that happened with balloons and all of this.
Indeed.
Tell the audience about that. This is
Indeed.
pretty cool.
Well, you know, NASA started planning for this eclipse about 3 years before it actually happened. You know, we created our science plans, our education plans, how we were going to tell the public, the outreach, working with citizens to support citizen science, and of course the #1 topic was really safety, how we could safely observe the eclipse throughout the whole event. Now, our science plan really had, as I mentioned, these 11 spacecraft, ground-based observers. We had the traditional things that we typically do, which is indeed observe the sun, this corona, and even that very lower part of its atmosphere called the chromosphere, and all the phenomena that we typically can't see even from spacecraft. So it's a perfect opportunity for us to take a look at that. All that traditional science. The difference between this eclipse and previous eclipses is really very simple. NASA goes to every eclipse, but we set up 1 or 2 sites. On this one, we had the entire continent of the United States to be our playground, and that was really fantastic for us. So we did some new science. One of the new things that we could do would be to launch balloons up to about 120,000 feet and really observe the shadow as it races across the U.S. Now, this was managed by Angela Desjardins and her team of students throughout the United States to be able to build these gondolas and get them ready and attach the balloons and launch them at all the right times such that they would be up as the shadow goes by and capture the beautiful science. But at 120,000 feet, that happens to be the temperature and pressure of the surface of Mars. This brings in some new concepts. This allows us then to think about, here is a natural laboratory. What can we do on these gondolas, knowing that it's be like sitting on the surface of Mars? And so on the gondolas, we had a very special passenger. And that particular passenger was a microbe. And this microbe, it's called Pentabacilla xerothermoduralneuron, okay, and I think I pronounced that right. But this little guy is really hardy. We find them in and around our clean rooms, and it's very hard to clean off. And of course, we want to launch and land clean spacecraft. We want to know the areas that they're in aren't going to be contaminated by humans. And so we want to know if this microbe ended up catching a ride on our rovers, whether it would survive on Mars or not. So the very simple idea then is, if we can put them on these balloons, get it up to that 120,000 feet, that Mars-like environment, and then recover these gondolas and see how many would survive. Now, to be able to do that, we created what we call a coupon. Now, on this coupon, it's a little metal strip about the size of a card, a personal card that you would hand out. These white dots, underneath these white dots that you see here, are the microbes, okay? And so they're counted out and put under there, and we've got a certain number of dots, and we have another identical one that we call a control that we keep here on Earth. And then we attach these to the gondola, okay? And the gondola, which is a small little package that has a camera that's going to look down and see the shadow, we also, as you can see here, applied that coupon with this microbe. And then we launched them. Now, we couldn't get them on all 50 balloons, but we could get them on 30. And they went up to 120,000 feet. The balloons exploded after a couple hours of being up, and the shadow moved by, and then the gondola would come down and GPS would allow us to retrieve it and bring it back into the laboratory. Really an exciting opportunity to study a new and unique environment by using our own eclipse.
Wow. When do we expect the final results to come out?
Well, you know, microbiology is really one of the toughest and hardest science. We don't do it quickly either because we're looking at such very small objects, very small microbes. And so they're making great progress. We anticipate that results will come out by the end of the year.
And the balloon release, what was going on with that? I mean, I know you sort of talked about that, but can you go just a little more detail before we get into some of your personal stuff with the eclipse?
So indeed, the 50 balloons that we had were arrayed along the path, and the balloon launches were done by students. Here you see the students launching the packages. At the very end of the line is that small gondola. And these balloons would go up to 120,000 feet before they'd continue to expand and then pop. They're latex balloons, and that's what makes the experiment really wonderful. They'll stay at that altitude for perhaps an hour to 2 hours, which is plenty of time for us to really understand what happens to the microbes that may be on our rovers on Mars. Now, the microbes were put together, that whole experiment was put together by Dave Smith, his team of students, not only at Ames, but at JPL. So it was really a wonderful collaborative NASA activity that we pulled off.
That's just amazing how we can engage also the students in such amazing science projects.
It really is.
I have another question. Like, how was your experience with the eclipse? But first that you tell me, let's watch this video.
Okay. Go back in memory lane.
I want to put on my glasses too and take a look. Can we continue this conversation?
I have to do this too.
All right, and watch, and we can talk.
Oh, wow!
Oh my gosh!
There's Venus!
Oh wow!
There's Venus!
Look like you having a good time there.
I was, you know, as a scientist, all my whole career in studying space weather, studying the sun and the planets, you would think I would have seen a total solar eclipse before, but you'd be wrong. This was my very first one, and it was spectacular. You know, I didn't realize it was on my bucket list until I experienced it. It was that good.
If you're just joining us, we're here at NASA headquarters on NASA television. We're having fun with the sun, celebrating the one-year anniversary of the 2017 total solar eclipse across America. Send in your questions. We're going to have fun with the sun. Hashtag Ask NASA. And we're going to go down memory lane. Send in your pictures. We all remember where we were on this day last year. Hashtag Eclipse 2017. Bring them. We're going to post them. We're going to have fun. We're going to talk about the upcoming eclipses. We've got Dr. Jim Green here, my co-host Jody here, an expert in space weather. We're going to talk about that, but we're just going to have fun. So, again, social. Let's go to the social questions. And again, hashtag Ask NASA. So social media is abuzz. We're celebrating a one-year anniversary. And we have Twitter user @OpenDawn asks, how many solar eclipses, both partial and total, happen annually?
Well, we get about one every 18 months, okay? And so that happens somewhere in the world, and it's been 100 years since we've really had one that cuts across the United States. So we've been very lucky to have it in our lifetime. But we have other opportunities coming up, too.
Good. Okay, so the media. Okay, we're doing social and media. Okay, here we go. From Tom Risen from Aerospace America. Was there any research from the eclipse that led NASA to add to or adjust heliophysics goals for the Parker Solar Probe? And we're going to be talking a lot more about the Parker Solar Probe that just launched. So don't change that channel. So what do you think, Dr. Green?
Well, you know, Parker Solar Probe is indeed going to fly through that area that during the eclipse we actually could have seen. And so those details change all the time. This is one of the reasons why we keep following eclipses. That area that we can't see from spacecraft changes constantly. And so we're constantly looking for new phenomena. I'm sure a lot of that data is still being studied and analyzed and may fold into some ideas about what we'd like Parker to do.
Okay, let's go back to social media. Keep those questions coming in. Hashtag Ask NASA. Twitter user at LDomsAsk, does the sun spin on an axis? If so, at what altitude would be a solar stationary orbit? Well, that's a pretty good one.
Oh, I like that question. You know, as a planetary scientist, I can tell you this. Everything in our solar system spins, and so does the sun. You know, but because it's a big ball of gas, its rotation rate is different at different latitudes in the sun. So for instance, at the equator, it will go around once every 26 or 27 days. But at the pole, it might be as long as 33 days. And we know this by looking at the sunspots and watching them go around, and at different latitudes, those that are at higher latitudes seem to go around the sun slower. And that's the dead giveaway about how that sun spins.
Now, before we take some more questions and keep sending those questions in, Jody, I mean, as a space weather scientist and with the eclipse, what were your personal feelings? I mean, we had an incredible adventure last year, but looking back and now, how do you feel?
It was an amazing experience. It was actually my first total solar eclipse, as Dr. Jean also said. And I couldn't believe how amazing it was until I was actually there. So it's a great statement to say. We didn't see totally because a cloud came in right on the time that it was happening. But we did, you know, experience the lowering of the temperature, the changes in the light, and also the people around us. The crowd was so amazed, and that energy transferred to everybody. It was amazing.
But I still have that energy, and it's showing up on social media. So we've got some more special guests coming up. So we're going to keep having fun with the sun, celebrating the 1-year anniversary of the one total solar eclipse in 2017 last year, the 1-year anniversary. One more question from Twitter user at TrueDrew97. I like that, True Drew. That's a cool name. So why was this eclipse so important for studying the solar corona? Were the observations made as significant as we hoped, right?
Yeah. So as I mentioned, every time we look at the sun, particularly during solar eclipses, we see regions we can't even see from spacecraft. These are important regions because we know the upper part of the atmosphere of the sun is really hot, the corona. And yet, I mean, it's so hot, it's so much hotter than the surface of the sun. And so we're looking at that region that transfers that heat up to the upper part of the sun. And we still are a little baffled by how that happens. And so we still need some additional data. And I think these kind of eclipses really provide that opportunity for us to do that.
They do, because as space weather forecasting, we actually do artificial eclipses to be able to see those explosions of the sun, but with the the moon actually covers the sun in almost a perfect way that you see parts of the inner corona that you don't usually see.
So it was a good year for solar scientists.
It was a great year.
Physics. Great year. So Jim, there are a lot more questions coming in, but we've got to bring in our other guests on show on time. I want to thank you.
Oh, my pleasure.
We'll look forward to the bacteria results that you talked about, and the incredible work that was done with the balloons and all of the other types of activities. If you're just joining us, we're celebrating the 1-year anniversary here at NASA headquarters with the total solar eclipse of 2017 across America. Send in your questions at #AskNASA. And of course, down memory lane, send in your pictures on that day last year, #Eclipse 2017. Now, we're going to transition into something that it just floored me, and that was the public impact of this. Now, there are lots of events that people go to and talk about, sporting events, entertainment events, historical events. This one just shattered all records on public engagement, Yadi, and we have someone that's going to even give us even better details and more details on just how impactful this was.
Yes, here to let us know about this amazing report is Dr. John Miller from the University of Michigan. Thank you for being here with us.
My pleasure.
Let me start out, John. about this report that talks about the impact what drove this report? Why was this report done?
Well, I have been studying scientific literacy for about 40 years. I'm a political scientist, but I'm also very interested in how citizens participate in a democracy on certain kinds of scientific questions, and we think that they need to have a certain level of literacy to be able to participate in that usefully. So I've had a cooperative agreement with NASA for a few years now, and each year I do a survey in the beginning of the year in February, and then we do a follow-up with the same people. This is a national sample of adults, and we do it in the same end of the year in November, December. And then as I had predicted to NASA a long time ago, in any year some exciting things will happen between February and December. And in 2017, of course, the total solar eclipse happened. And that was a remarkable event that it was the first time in over 100 years that's happened in the United States. But also, it was one of the first times that an event like that has happened in what we call the internet era. Because many things we look at that were 50, 60, 70 years ago, you can't really compare the participation of people because there was no internet, there was no cell phones, there was people had to wait for newspapers 3 days later. Here we have instantaneous communication, and we had a lot of ways for people to find out about it, not only before it happened, but after it happened. And so it was an extraordinary opportunity, and we hope that it stimulated enough interest in science and what we're trying to keep following is to see how much impact it has had, not just for the moment of the viewing, but in the months and years thereafter.
Well, this is fascinating. So let's talk about the path.
Okay.
And I think that obviously had a lot. And then let's go into, through the eyes of NASA, what did NASA bring to the table? I mean, we brought the eclipse that nobody else could do. But let's talk about the path first.
Well, the path was extraordinary because it started essentially coming in almost over Oregon and went to South Carolina. And it occurred midday, by and large. It was in the middle of the day. And that has some advantages and disadvantages. It also happened in August when school was not in session, which was a little bit of a disadvantage because had schools been in session like they are from September onward, no doubt the numbers of children would have been much higher because the schools would have embodied that. But NASA, very thoughtfully, beginning 2 or 3 years before that, began to partner with public libraries and with all kinds of groups, Girl Scouts, Boy Scouts, all kinds of different organizations across the country, to prepare people to think about this and to weave it into their activities. So in fact, what we found was that 154 million people actually went out and watched it. And another 25 million saw it electronically. And I'm sure many of that 25 million would have seen it if their job or something hadn't kept them. I mean, if you were a surgeon, you'd like your surgeon not to stop and run out and look at the eclipse. So there's some places where you can't do that. But together, we had 215 million people or so who saw it either in person or saw it electronically. And that is, as far as we can tell, the largest single event of its kind, of any kind, entertainment, sports, or other things. It's also just symbolic of the era that we're entering, because in the electronic era, people will be able to seek information and find it and do things in a way that they could not have done 50 or 100 years ago.
In your opinion, how do you think this actually impacted children, the new generation coming up?
Yeah. Well, we actually did not survey children, but I have been spending most of my last 30 or 40 years looking at how children learn about science. And I think that one of the things that we know about that is children have a great deal of curiosity, sometimes more than their parents have. And we find, in fact, some adults tell us they get involved in science because they're helping with a science fair project or something like that. So I think when children see their parents expressing interest in something and going out and getting glasses, making arrangements to see it, talking to their friends about it, and all those things, that really says to a child, this is important, and one should try to understand some scientific things like this. So I think as a role model, it was a terrific opportunity for many children to see all the adults around them that were really behaving responsibly first by getting glasses, and secondly, by seeking information about it. We know that in the 3 or 4 months before that, the average American made about 15 efforts to get information online, reading magazines, doing things like that. And we know that after the event, they continued to seek information, and they got essentially another 15 sort of looks on the average. Now, that's an average, so some people did a lot more, some did somewhat less, but it really does illustrate that an event like this not only causes people to prepare for it and look for information, but it really has an after effect where after having seen it, now they want to know more about it. So I think one of the programming lessons for NASA and for educational institutions of all kinds, libraries and other groups, is that you should not only just program before an event happens, but you should think about the information needs that people have after the event happens. Mm-hmm. And I think that this report will demonstrate very persuasively with really hard numbers that there are millions of people seeking information after an event, not just before the event. And so I think in that sense it was a very useful event for us because you can't stage something like that artificially.
So before we take questions, and the report sounds like it was pretty impactful. You have a graphic that kind of illustrates.
Yes.
Let's talk about that.
Well, we have a graphic which you can see that runs ever since Sputnik. The first survey that you see on that left-hand side, which I did not do. I was a high school student back then. But it was done actually by the University of Michigan. And it was done a couple of months before Sputnik. And you can see at that point of time, about 10% of Americans said they were really very, very interested in things related to space. But as we go on, it gets up into the 30s and so forth, and then it dips a little bit. It just certainly during the post 9/11 period, it dropped off a little bit, but it's coming back, as you can see. And the level of interest, and those last two dots show you that the level of interest was going up before and after the eclipse. So that there's a little bit of growth there. Now, the other two lines are interesting because it shows long-term growth. Because for people to become involved in space policy, they have to do two things. They need to have a high level of interest in it, but they also need to think and feel that they're reasonably well informed about it. Almost nobody writes a letter to a congressman or a senator and says, I don't know much about the senator, but here's what I think you ought to do. That doesn't happen. Sometimes when you read the letters they send, you may think they didn't know a lot, but on the other hand, the person who writes it has to believe that or they don't participate. But the red line is the people who have both. And those are the people in our population who are really active in policy discussions. So if there's a question about, how much resources should we put into the Mars program, or should we, how should we have continued Hubble and things like that, that attentive public is a crucial group. And in just that short period of time between January and November, December, that increased by 1.5 million. So there was a lot of adults who, before the eclipse, probably didn't think of themselves as being especially attuned to science policy or to space policy or space exploration broadly, who after the event, about 1.5 million of them increased. And we think that will be a long-term, we're going to keep monitoring that. But it is, I think, an example of how you can build a long-term core of people who are both informed and who want to be informed, and that becomes a basis for people then seeking scientific information.
Wow. Well, it just shows you that, science has no boundaries. I mean, race, gender, people love it. And so, there are a lot of educators tuned into the show today. So let's go to social media at Stardust Spec. In the Midwest, many schools were in session. So was there a difference in engagement for states with schools in session? It was our first day of classes at Mizzou. Thanks for the question.
That's a good question. And the answer is I really don't know. Most of the Midwestern schools in the states that I was familiar with, I happen to be in Michigan at Ann Arbor. I have spent many years in Illinois, and I was raised in Ohio. So my sense of the Midwest was that most schools were not resuming until after Labor Day or very close to it. So maybe I think Missouri is a little ahead of the curve. And you're starting a little earlier than some other parts of the country. But I believe that generally across the country, there's only a small number of schools that are in session in mid-August or by this time of the year, 21st of August. So we do not know that by which schools were in session. And we did in fact survey adults. It's very difficult to survey children. You have to be able to draw a sample, you have to be able to find them, you have to get their parents' permission. It's a different ball game. And so we did not survey children. But we thought that the schools would have been a place where, had they been in session and organized, that millions of children would have seen it in an organized setting. But I think that Missouri and the person who asked the question is just a little bit ahead of the rest of the country in that regard, because I don't think most of the country was in session.
So we're going to wrap up here, but if folks want to see the report, where should they go?
Well, I think it's on, I believe it's on the NASA website.
Yes.
And so they can look at the NASA website and find it. That's probably the easiest and fastest way. So at nasa.gov, and I guess at NASA Science at NASA.
There we go.
Yes.
Well, John, thank you. And again, if you're just joining us, welcome to the one-year anniversary show here at NASA headquarters, celebrating the one-year anniversary, 2017 total solar eclipse. We heard about the public engagement, the impact, the numbers. Check out the report at nasa.gov. And as we continue this show, having fun with the sun, send in your questions at #AskNASA. And again, we're going down memory lane. We're taking a look back. We're taking a look forward. Send in your questions so we can, well, send in your questions, but also send in your pictures where you were. Johnny and I remember, and our next guest was part of the solar band, I call them, where we down in Charleston. But send in your pictures at #Eclipse 2017. Woo, John, that's a lot.
That's a lot. Let's talk a little bit more about what is upcoming next. You know, there's a lot of things that NASA is actually doing now for, sun science, and it's amazing. Eclipses are very important, and like we said, they're very important also for the part that we call space weather. We see parts in the corona during the eclipses, the total solar eclipses, that we don't usually see. Parts of the corona where solar storms originate. Right there, you're actually looking, you're going to see things that we actually do, like artificial eclipses, that actually cover more of the corona that we actually wanted to, but it has to do with the distance of the instruments to the sun. The moon covers the sun in almost a perfect way, and we see that part of the corona in a corona that actually those solar storms originate from. And it's an amazing thing that we can actually do during total solar eclipses. And to talk a little bit more about that and, space weather effects, which can affect instruments in the satellites outside in space, and also can be dangerous for astronauts, is here my colleague, Dr. Alex Young.
Hey,
Alex.
it's good to be back with you guys.
Yep. The shoes, right?
The shoes.
Gotta show them the shoes. The shoes. The guy who has the most famous shoes, one of the coolest scientists. It's good to see you again, Alex.
It's good to see y'all.
We're getting the band back together.
That's right. That's right.
Other folks.
It was a great day, I tell you. It really was a great day. And one of the things that's been so cool about it is, I've taken a real interest in trying to look at all the science that's happened. Some folks asked me to put together some information and write a paper about all the different types of science. And it is mind-boggling how much science came out of this eclipse. So one of the things that we talked about is the sun. The sun is incredibly important. It gives us light, it gives us heat. It is what makes our lives possible. But as Jari mentioned, it produces a lot of activity that impacts our lives, and in particular today, because we are a technological society, and all of this stuff coming off the sun messes with technology.
Let's talk about something that just recently happened. As we're talking about the sun, an incredible mission that took place. Let's talk about that.
Absolutely. So we were fortunate to go down to Cape Kennedy on August 11th. Was the originally scheduled launch of the Parker Solar Probe, and the launch occurred actually on the 12th, the morning of the 12th. And so what you're seeing here is a Delta Heavy. This is NASA's biggest rocket, because we need a big rocket to get something to the sun and we also needed to use another planet, Venus, to help us get there. So we've been talking about the corona, this part of the sun that you see during a total solar eclipse. Well, we've been looking at it from a distance for actually centuries, looking at it during total solar eclipses, looking at it with space-based instrumentation, but looking at it from a distance does not give us enough pieces of the puzzle. And in order to really understand the corona and understand why it's so much hotter than the sun's surface, as Dr. Green mentioned, why does the sun's atmosphere stream away into space, and what is really going on in the corona that's producing space weather that's impacting us, we need to send a spacecraft there.
So I got a little toy here. I'm sure you guys recognize this. And the technology on this thing is pretty amazing. How does it, you know, we get questions, what keeps it from burning up? I mean, you're getting so close to the sun.
Well, there's a couple of pieces of technology that are amazing. So the first part is the shield here. The shield is 4.5 inches thick composite carbon foam and fiber. And also, we have a really well-designed radiator system, so well-designed it only uses a gallon of regular water. And that's just crazy, but that helps get rid of heat. And so in a combination of those two, we take temperatures that are 2,500 degrees on the front of that spacecraft, and behind it, where this instrumentation is, it's a cozy 85 degrees.
Yeah.
Really?
Yeah.
Yes. Very cozy.
Yeah. So this is another piece of the puzzle. We are getting such great science from eclipses, and now we're adding this. And we'll actually be talking shortly about upcoming eclipses. And in fact, when this spacecraft makes its closest approach, it will be around the same time as the next total solar eclipse in the United States.
Wow. You know, Johnny, and you talked about, let's talk more about space weather, because people don't understand how important that is. Explain what space weather is and why people should really care about it.
Well, like I said, you know, there's a lot of activity that happens on the sun that can affect, like Alex said, our technology here. Space weather can actually affect the instrumentation on the satellites in space. It can be dangerous to astronauts. It can affect GPS signals. You know, GPS is used for a lot of things, credit card transactions, agriculture, things that we use every day, that is important to have it because we use it. Not only that, when those solar storms are really, really strong, they can actually affect power grids. It has happened before. Cities, big cities have been without power for many hours because of the sun's activity. So it's really important to have, a type of space weather forecasting capability. And Parker is an essential mission to let us understand that part of the corona. And with that understanding, we can actually improve the models that we use for space weather forecasting.
I see the sun and it's in different colors, and I mean, what does all that mean? I mean, it's green and then it's orange and then but you scientists know what that means.
Well, so we only see the sun in visible light. In fact, invisible light is too bright to look at it directly, except during a total solar eclipse. But from space, we can look at the sun in other wavelengths of light, wavelengths that don't make it through the atmosphere, which is good for us. But ultraviolet, X-ray, gamma rays, for example. Now, the images that Jari has been showing of the ultraviolet or extreme ultraviolet sun, so you see the green, the gold, the brown, those are actually originally black and white or grayscale images. We color them so we can distinguish between the different wavelengths, but that's just something that we add to it because we don't actually see, these are not invisible light.
No. And that actually explains to you which temperature you're looking at. Exactly,
because as we've mentioned, one of the key things we're trying to understand, both looking during eclipses, and in fact we first discovered that the sun's atmosphere, corona, was so much hotter than the surface because of eclipses. Eclipses gave us the first glimpse into that mystery, which has been puzzling scientists for years, and we're hoping the Parker Solar Probe is going to resolve.
Well, we're going to talk more about eclipses. So I have another little toy here, and I mean, you solar experts, tell me what I'm looking at, and why is this important to study the sun? I mean, it's pretty vital.
This is a model, a 3D printed model of the predicted coronal magnetic fields, because it's actually all about magnetic fields in the sun's corona that are driving this phenomena, is a group called Predictive Science who predicted what would the corona look like during the eclipse. And in fact, this is one of the first science results from the eclipse. They did an amazing job. The agreement between their model and what we actually saw was astounding. And that's what you're seeing here in a 3D printed form.
You know, and the bottom line is the sun is so important, because without the sun, we wouldn't be having the show, would we?
That's right. We wouldn't be having the show. We wouldn't live here. The sun is our energy source. And it's also, as we've been talking about, something that we are susceptible to. It produces all this amazing, violent phenomena, and it messes with our technology. It messes with a society that is more and more technologically dependent. And so we have to use technology to understand what's going on so that we can make our lives better.
Well, as Jim Green said, you know, the sun affects everything, and we like to say we have a season of science coming up, but there's some pretty other cool missions coming up in the geophysics side, right?
Well, let me tell you a little bit about some of the different science, and then we'll talk about how that's connected to some of the upcoming missions. So we've talked about Parker. Okay, we've been looking at the corona from a distance. Now, during the eclipse, we actually used a lot of different things. We looked from the ground. We had colleagues at the Smithsonian, at the High Altitude Observatory, who were looking from aircraft, allowing us to look in, for example, infrared light. Colleagues used NASA planes, WB-57, giving us the first infrared images of eclipses. So all of that together is giving us a look at the sun's corona. But one of the things that's really cool is that when that shadow moved across the country, it changed the atmosphere. And so atmospheric scientists were able to study with this basically giant impenetrable cloud their models for how clouds work, how that impacts climate and weather in a unique way. And there's even another part of the atmosphere called the ionosphere. And that actually gets back to space weather. So the ionosphere is the outer layer of the atmosphere. It's the layer where aurora occur. And it's an electrical layer. And it's our connection to space. So scientists using that shadow as it's moving across the country, because we were going across such a populated area with such great coverage of instrumentation, we were able to see phenomena in the ionosphere that's been predicted since the 70s, but only measured and seen definitively now. And that is connecting with an upcoming mission we have called ICON. So ICON will be launching soon, launching from a Pegasus rocket that's dropped off of an airplane, and that's what we call an Explorer mission. It is going to fly into the ionosphere, and it's going to study it up close and personal. So just like Parker going to where the action is, now we're going to go to where the action is in the ionosphere.
Wow. That's pretty cool.
That's just amazing.
So what was your personal experience? We asked everyone that.
Well, I had a very similar experience because, of course, I was in the same location, and I will say it was disappointing. I mean, I've been working on this, working with the agency to plan for this for the whole country for many years, and it was a bit of a disappointment that I didn't see totality. But I do want to say that connecting with people was a huge part of it. And I'll even give a shout out to our colleague, Nikki Fox, who is the project scientist for Parker Solar Probe. She was in Beatrix, Nebraska, looking at the eclipse. And so when we were doing our broadcast, we showed Nikki describing what she was seeing. Like me, another heliophysicist who hadn't seen a solar eclipse yet. Her energy and her emotion was so powerful that while I did not see it myself, I felt it come through that monitor. And to this day, I credit her with imparting so much passion and excitement that I am ready for the next one, because I have a taste of how exciting it's really going to be.
You know, before we take questions, and you gave a shout out, and we're going to talk about the eclipse. We got these eclipse glasses, these upcoming eclipses. I've got to give a shout out to the folks who brought you, along with through the eyes of NASA, these are some of the folks, and forgive me if I do not. Please forgive me if I don't give you a shout out, but you know who you are. You know, obviously the aircraft, the balloon teams, the libraries, the national parks, the museum and science centers, solar system ambassadors. You guys are amazing. Keep it up. You guys are just phenomenal getting that science out. The Challenger Centers, the Globe and Kate sites. You guys know who you are. The Boys and Girl Scouts. And of course, we even had the Coast Guard ship. You guys remember that? So, and other government agencies, thank you, thank you, thank you. And you guys are, I'm sure, ready for 2024 and other eclipses. So let's pull out, remember I told you at the beginning of the show to find your eclipse glasses. So Alex, these things are gold, by the way. You remember? I mean,
these things were gold, and I do remember people were just going nuts trying to get their hands on these. But these things are so cool because, you know, I've had these. I had different earlier pair before the eclipse. These are not just eclipse glasses. These are solar viewing glasses. These are safe solar viewing glasses. You don't need an eclipse. All you need is the sun, and it's out there every day. You can go outside, put these on, look up, and you can see the sun in the sky.
And if it has big enough sunspots, you will be able to see them.
That's right. And now, though we're at solar minimum, where the solar activity is low right now, there are not very many sunspots. And they will still happen, even during solar minimum. We'll still occasionally get them. But then as we get closer and closer to 2024, closer and closer to Parker flying closest approach, and the upcoming total solar eclipse, you're going to be able to go outside and you're going to be able to put these on, look up, and see sunspots that are bigger than the Earth, and they're visible from here on the ground.
So if you still have your glasses, and I hope you still do, they're still, now they can't be crinkled or anything, right?
Right. Well, they can be crinkled, but they can't have holes in them. They can't have, you know, big scratches or anything like that. They just have to be completely solid, and when you put these on, you will not see anything unless you're looking up at the sun.
And make sure that they're certified.
Make sure they're certified.
The right ones.
Yep.
You guys remember, you know, there were some other ones going out there, but yeah, we've got ours. And if you still want get some glasses, you know, call NASA. We still got a few left over.
That's right. And you know, you can go to the Eclipse website, eclipse2017.nasa.gov, or eclipse.aas.org. Our colleagues at the AAS, who are the ones that really worked on making sure, you know, that we knew exactly what were the best glasses and what were the certified glasses.
Okay, before we talk more about the 2024 eclipse, let's go to social media. They're dying to ask some questions here. So this is Michael Cook on Facebook. I was in the line of totality in Oregon last year. I posted weather information from my location using NASA's Globe Observer app. You know, another shout out to the Globe program. Were there any new discoveries made from the public reporting data to NASA?
Well, there is a lot of data that's come out of Globe. I've seen some of the preliminary data, and it is pretty amazing because we have an extremely complete picture of how clouds and temperature have changed as the shadow moved across the country. So some of the results are still coming out. You know, this is one of the unfortunate things about science. It takes time. So it takes a lot of time. We get a lot of data, which is great, but it takes a lot of time to process it. But having said that, looking at the preliminary results, we have an amazing picture of what's happening in our atmosphere and changes in temperature and clouds as moving across. And it's all thanks to observers like him who've taken these observations with Globe.
You know, for this eclipse, we had so many vantage points, and that's why scientists and everyone just saw and studied and got more information than any eclipse, and even on the International Space Station, right? So, in fact, we have a question from social media at Pygmy3256. Oh, okay, that's interesting. Okay. Was the International Space Station in position to view the corona?
They were not. They were not in a position to view the corona, but they saw the shadow.
The shadow.
So, unfortunately, they were not aligned just right, because this is the issue. Eclipses occur all over the globe, but you have to be in the right place at the right time. And so, unfortunately, you had to be in that path of totality. And that space station was just moving too fast to stay under the shadow. But they could see it as it moved across the country. And it was a pretty amazing view. I would have loved to have been able to take a view like that.
Okay, so we're going to keep sending in those questions, but we're going to be wrapping up here shortly. But before we do that, let's give a little tease for the next total eclipse across America. We've got a couple coming up. Let's talk about that, but then let's talk about 2024.
Okay, so we'll go through them real quick. We've actually got eclipses coming up in 2019, 2020, both of them in South America. The first one in Chile and Argentina, and the next one is in primarily Argentina. 2021, there's one in Antarctica, a little bit harder to get to. 2023, there's actually one across the western U.S. It's not a total eclipse, but it's an annular eclipse. So it's still going to be good. You need these because you won't have totality, so you always need these glasses. Only time you can't use these glasses is when there is totality and you're in that path. But that's when the moon is not as big as the sun, and so there's a ring of the photosphere and the chromosphere around the edge. Still a very unique opportunity, but 2024. This is a great year for a lot of reasons. From a solar physics point of view, we're getting close to solar max.
Yes.
This is when the stuff is really happening, when it's going to get exciting. The corona is going to start producing lots of cool stuff leading up to that. More solar flares, coronal mass ejections. Parker Solar Probe is going to be flying its closest approach through there, and at not exactly the same time, but close by. We're going to have this eclipse 2024 starting in Mexico, working our way up through Texas, Ohio River Valley, upstate New York, New England, Canada. Longer totality, on average more like 3.5 to 4 minutes everywhere. The path is wider. It's going to be April 8th. I think it's a Monday. I can't remember. I think it's a Monday. This is going to be a spectacular year. I mean, this is science. The sun, the atmosphere, the moon, it's going to be fantastic.
Imagine having a coronal mass ejection during that total.
That would be amazing. That would be amazing. And they've been seen in the past. It is very rare. People have asked about Parker. Parker would like it if there was some activity. You know, it's made to handle it, and that would be fantastic. But if we could see that during an eclipse, that would be amazing, because we're going to do similar things. You know, this last time we had many sites along the path. In particular, the Citizen Kate, we had 60+ sites along the path, which you could stitch that together and have a long observation. We have 80-minute observation of this last eclipse from stringing together all these observations. We do this again during solar maximum. We have a much better chance of some activity, and seeing that from the ground would really be some exciting science.
Wow. Well, that's going to do it. You know, we can talk about this.
I can talk about it all day.
But thank you. We're going to wrap up here, but it's not too late. In fact, one of the lessons learned is get your hotel reservations, get here really early, because if it's anything like last year, it's going to be even better in 2024. So just a reminder, this is going to be the season for science. What do I mean by that? And we've been having fun with the sun, but there's so many other things going on in NASA science. This fall, a mission to an asteroid, a landing on Mars, the Earth science. They're getting ready to launch an incredible mission. We've got Pluto New Horizons, all of these missions, and it's about NASA science. I'm Dwayne Brown.
I'm Dr. Yari Collado Vega, and thank you so much for joining us.
And thank you. And when it comes to NASA science, science never sleeps.
Never.